Today we are going to see about DC motor construction and working. See, so DC motor is a direct current. The electric motors are most important element in this today's world. From a simple drill machine to a sophisticated robotic arm, electric motors are used everywhere. The main types of this DC motors are the electrical motors are AC motors and DC motors. In this, because of some important characteristics like fast reaction and better speed control and simple construction, DC motors are very popular in automatic machines. Here it is the AC motors. This is the DC motors. See, this is the construction of DC motors. This is the stator part and this is the frame. This is the pole. The outer part of the motor is generally known as a static, which is a stator side. Here in the DC motor, stator is a static part. The stator consists of a frame and it consists of pole shoots which are protected. See here, this is stator, this one is frame, and this is the pole. Then you will see the core of the DC motors. This is the core of the DC motors. These core poles are made from silicon steel on which insulated copper wire is wound to make the windings. These poles are bolted and fixed inside the frame. See, these poles are fixed inside the frame. Then, when the DC current is passes through the winding, it creates a static magnetic field. These are two types of poles in the DC machine, which one is main field pole and interpole. If you see here now, it is a DC current coil. If you are pass through the windings for a DC current, then the magnetic field will produce. This is the main field pole and this is the interpole. Then the connection of this pole are brought out connections in the terminal box so that we can give electrical supply to them, and even to check for the fault we can easily find out the fault also. The main poles create a static magnetic field when current is passed through the winding. Then the rotor side. In this magnetic field, rotating part of a motor lies known as a rotor or armature, which is made up of by number of something of highly permeable material, which is a silicon steel, which allows a magnetic field to pass through it easily. See, here there is a stator is a stationary part and here the rotor is a rotational part. Then the slats. The slats are cut on the outer peripheral of the rotor, or we can say armature, which receives the coils or windings made up of copper conductor. Then each coil gets connected with an external DC source by a pair of commutator segments arranged in the form of a ring. Here you can see this is the slot one and this is the commutator. Then this complete assembly is housed over on a cylindrical shaft made up of high quality steel. This is the cylindrical shaft. Because of this bearings at the both side of the shaft, the rotor is capable to rotate between the field poles. See here the field poles are there. So it should be rotating easily with the help of these bearings. Then the working of DC motor, how it will work. See, when electrical current is forced to pass through the rotor conductors by certain Darwin press through the commutator segments, it creates the own magnetic field which tries to discharge the magnetic field created by the field pole. See, when we are giving the supply to this carbon brush, here the carbon brush and it will connected with the commutator. This commutator will connected with that magnetic field, then that magnetic field creates that magnetic force. That magnetic field created by the magnetic pole over here. Then due to interaction between these two magnetic field, which is magnetic field of main poles and the rotor conductors, the electromagnetic force act as a rotor conductors, and these forces act tangentially at the rotor surface. Therefore, torque is produced at the rotor surface and the rotor gets rotates. So initially we will give the current supply to that particular carbon brush. From the carbon brush, the commutator will receive this current. Then this commutator will supply to the particular rotary magnetic field. From that rotary magnetic field, it will rotate the rotor side of the machine. To understand the process more easily, let's we take the example of single loop having sets of one combinators. See here we are having the loop. This is the these two is the commutator segments. Right? Due to the DC voltage applied to the external DC source, the current will flow into the coil. The current is flow through this coil. Then a given direction from positive to negative potential and by the plumbing left hand. Then we can find out this side of a coil receives a force on upward direction and this side will receive a downward force and hence this loop will get rotates. When we are connected to this coil to the external force, then the electromagnetic field will produce over here. Then this electromagnetic will act with the plumbing electron rule. See here the force will occur, here the fields will occur, there is a current will flow. Like this the operation will take place. And during this rotation of the loop you can find the commutator segment come into contact with the brushes and the opposite polarity one by one. This way the conductor of the left side always carry current in given direction and right side is in the opposite direction. See here it is in this direction, this is the opposite direction. Then this helps to maintain the continuous rotation of the coil. Then you can also find the magnetic force of the coil is maximum in this region. After that magnetic reduced to considerably. This causes uneven torque and movement of the rotor. To make the maximum torque always available at the shaft of the rotor, multiple number of coils with a pair of the commutator segments are placed in this rotor. So if you need a maximum torque for that available shaft, the rotor multiple number of coils with a pair of commutator segments are placed. Here the commutator segments, the more number of commutator segments pair are placed over the rotor to make a maximum torque overall. Then when coil passes through the region of maximum torque, the next coil will take its place. This way, shaft of the rotor always provide higher and smooth torque. Then these coils are connected with the commutator segments in such a way that every instant time each of the coil carries a current. But the size of the coil comes At the left hand side carries current in one direction, and the other side of the current carries in opposite direction respectively with the rotor position. Because of that rotor position, current will take right side as well as the left side. Can be achieved by the lap or wave winding connection. There are two waves winding connections are there. First is lap and another one is wave winding. To ensure that the current given to the commutator will not reach that soft mica insulation placed between them. These are all about the DC motors.